Okay, it's 1:45. We'll make a start now. Hi, I'm Alan Burrison. I'm MD of EcoCooling, and I'll try and keep you entertained for the next 20 minutes talking about some of these radical projects we've got underway all around Europe, and try and share with you some of our experiences of the way the world is changing. A gale of creative destruction. We think this is a great economic expression. What we're seeing out there is all these new applications arising. Gaming, artificial intelligence, driverless cars, blockchain, artificial intelligence, Internet of Things, cloud-based hosting of things. What this is doing is driving a different approach to data centers. Data centers are changing dramatically, and we're very fortunate in that we've been at the front end of many of these very, very radical projects. What you will have seen over the years is the big guys building these hyperscale data centers. Facebook, Microsoft, Google, Amazon Web Services. They all, you'll notice there, they all look very different, using different technologies. Facebook at Luleå using fresh air, Google using cooling towers and middle temperature water systems. What is common about all of these is none of them are using conventional refrigeration systems. What's common about them all is that they're breaking the mold of conventional racks, conventional power, conventional metrics. They're doing extreme engineering here. Now, what's happening now is that let's say the smaller guys and the entrepreneurs are taking similar approaches. Why are they taking similar approaches? It's because the standard data center, which is populated with CPU-based technology, which is very flexible, all your standard servers, etc. The CPU is a jack of all trades, but not particularly efficient at any one. So many of these new applications are demanding higher levels of processing capacity. And we're seeing a migration of work away from CPUs into high-performance computing, these things called GPUs, graphic processing units, which I'm going to talk about in a moment, and things called ASICs, application-specific integrated circuits. So, what we're going to get into over the next 10 minutes, 15 minutes, I'm going to show you how people are building these radical facilities based around radical fresh air systems to host and house these new styles of data factories. Many people have never even seen these beasts, okay? So you look at that first device on the top left, that's an Antminer S9. They probably make 100, 200,000 of these every month now in China. 1.5 kilowatt unit stacked out in facilities by their thousands, by their tens of thousands. An astronomical level of processing capacity. Beneath that, you've got a GPU, a graphic processing unit. Okay, and that's more conventional. Now, Now, an ASIC can only do one thing. Unprogrammable, and typically you buy a Bitcoin ASIC, it mines Bitcoin. A GPU can do a number of things. It's very programmable and more, let's say, more flexible for the future, but not quite as dense. So what we're looking for, and the cooling issues that we've got to address. In a normal data center, you will see, you know, the typical 32 amp, 16 amp racks, up to 8 kilowatts. The average density in the UK, they tell me, is 2 to 3 kilowatts per rack in standard co-location or enterprise data centers. Very few people stack up the full 32 amps to make 8 kilowatts. Lots of resilience in your normal data center. A and B power, A and B comms, N+1 cooling, 2N cooling, 2N+1 systems, tiers 3, 4, that type of uptime. What do we see with this high performance computing, blockchain? Don't get all this, don't be overwhelmed with the thinking it's all about Bitcoin, right? This is high performance computing. And what these guys are doing now is we're putting it up to 75 kilowatts a rack. This is a crazy level of density. It's beyond belief for guys who operate in normal data centers. Okay. No redundancy at all. Just power. Just fresh air. Maybe a little bit of redundancy on comms. Standard racking isn't really appropriate for them. Customized racking, building a wall of servers. You see that in the bottom there. Those ASICs there, probably stacked in racks 3 meters, 3.5 meters tall. These are real processing factories. And all of it cooled with fresh air systems. Why? Because it's about total cost of ownership. This total cost of ownership is what these guys are used to, right? What they're looking for, and we've all got our metrics of PUEs and energy efficiency ratios and things like that. What the modern, latest data factory is measured in is just cents per kilowatt hour of installed equipment. And so what we're seeing is that cost absorbs everything. I give you a 1 kilowatt device, look after it for a year, I want to spend 8,760 hours times maybe 6 or 7 cents in the Nordics, maybe 5 cents in China. Now in the UK, we can't even buy the electricity for that. Okay. 12 cents, something like that. Okay. However, all is not lost for you guys because these are very valuable pieces of equipment, and not everyone wants to push their equipment out into China or the Nordics or to Iceland or places like that, or out to Washington State where there's cheap electricity. We've got tens of millions of pounds worth of equipment, and people are now looking at significant investments in Europe to support that. So we're seeing the higher cost countries now come online and building bigger facilities. But they still have to follow the same principles. What do they do? It's all about simplicity, obviously. You can't build anything complicated for low cost. So there are some common elements on this. We've got brownfield sites. We look through the Nordics, there are paper mills and textile mills and warehouses with lots of spare power where people can move into brownfields. Or building latest design modular constructions. Modularity is becoming key to all this. How do you achieve lowest total cost of ownership is also 100% utilization. Guys who've got your own internal metrics in data centers will probably appreciate that most conventional data centers are probably only half utilized. Half the available power is actually used for real equipment. Then when you get out to processor level, some blade servers are in single percentage points utilization. That's not how you survive in the modern world of data processing factories. These guys squeeze all their assets to 100%. No capital cost taken in any forms of redundancy. Direct fresh air. We can't afford to use chilled water DX. Also, many places just haven't got the space for that. So what we've got is a whole series of challenges here about looking after these places. Just as a slight aside, as EcoCooling, we've just won an award for a grant through Horizon 2020, which is a European fund to increase data center efficiencies and make Europe a more competitive place for data centers. And over the next 2 years, we should be building a test data center in Sweden with the objectives of measuring and disseminating information for you guys to then look at, absorb and take your decisions on. Got some clever guys involved. H1 Systems are the project managers from Hungary who will be building this construction. It's built in conjunction with Boden Business Agency out in the north end of Sweden in the Arctics, who are helping us with the land and the planning. Fraunhofer from Germany, who are the analytical guys, looking at optimization of the complete data center, balancing cooling, power, processing, around all sorts of different applications. And SIS, the Swedish Institute of Computer Science, Torbjörn Mind and his team, who are the theoretical experts who are also looking at optimization of things like the open compute. So in this building here, this is a radical design. This is a single structure which can accommodate all these different types of equipment, from open compute, like your Facebook style racked out open compute equipment, conventional IT, high performance computing, GPUs, and then at the left hand side we've got ASICs, these Bitcoin miners. This could be the most densely stacked out data center in the world, or over 100 kilowatts per meter of linear meter of the building. But based on a modular system. So each of those little groups there can then be put into that fishbone type of diagram. Now, these sort of things that we're heading for here is this, trying to create this easily achievable engineering standards so that people new to the market can put together projects which will be equally, if not more efficient, to the big guys of Amazon and Google and Facebook. This should hopefully give everyone the opportunity to do that. Now, one of the key components in the middle of this is where we come into the cooling system. And we're trying to break some records with this pod here. So we've got lots of fresh air. So in here, this is a 3-cooler system, 15 cubic meters per second. What are we trying to do with this? We need it low cost. Right. So the low cost we're looking for is we're looking to build data centers at less than 1/10 of the running cost of a conventional. Sorry, 1/10 of the capital cost of a conventional data center. Conventional data center can cost £5 to £10 million a megawatt. Let's try and build data centers with $300,000 to $500,000 a megawatt. Now, to do that, you've got to be pretty slick. So this system here, 15 cubic meters a second, can look after 144 amp miners, over a quarter of a megawatt, in a 3-hour build time, including power distribution. These hyperscale data centers, things have got to be done fast. We have clients who are wanting, the people in this room are looking at putting in 3, 4, 5 megawatts a week of equipment. You're not going to do that if it's complicated, are you? This modularity, everything integrated and low skill. Even in the established industrial countries, we can't find the numbers of people to do these installations. There aren't enough electricians in Western Europe to put these together at the cost we're trying to achieve. So an integrated rack, integrated cooling, containment and racking system appears to be the way forward. So then we leave everything up to simple plannable external work. Power distribution, PDUs, everything fully assembled, totally plug and play. The name of the game going forward for these systems, plug and play, rapid deployment. That's what we're going to see. That's the way that we're going to match the rest of the world in this rapid deployment for these new technologies. And maybe we can get our total cost of ownership for that part of the infrastructure down to less than 1 cent per kilowatt hour. You remember that value of this 5, 6, 7 cents per kilowatt hour? We've got to have this infrastructure to house this equipment. Now, if we're using less than 1 cent on the main part of the capital, now we've just got to find a building, now we've just got to find this transformer, get some comms into it, then we stand a chance of competing, don't we? Right, and you're not going to do it with any of the conventional solutions. I'm now going to show you some installations. This all sounds very straightforward until you start to do it. Hydro 66, one of the early leaders in the Arctic data centers. Once again, extreme engineering. Here, in these buildings here, we're changing the air in these buildings every 5, 6 or 7 seconds, okay? These are like a wind tunnel. We move the air through the buildings at 30 miles an hour. These guys have got -30, -40 degrees centigrade. So, you guys who are looking at developing your own systems, I recommend you do 2 things. One, you look at your own engineering, but maybe the lowest cost option is to go to some of the established players in this market. Okay. We've got to look after this equipment. Don't forget, these miners might cost €3,000. 144 miners in each of those pods. 144 times 3 grand is a lot of money. Okay, we need to create compliant conditions. So one of the radical things we've done, you're probably familiar with ASHRAE standards and things like that. What we do have in our conventional cooling systems, we're actually able to achieve almost total compliance in the northern parts of Europe with no refrigeration, no chilled water, no DX. This is potentially the way forward for lowest cost operation and simplicity. We can achieve 100% compliance with 2 mixing dampers, a fan and a filter. That then becomes achievable to manage these hyperscale operations. Few patents to look after all this. A lot of science behind this. All looks very simple, but these are extreme buildings. Here's another guy that we should be commissioning over the next few weeks, BLOCKBASE. That's a 16 megawatt building, once again in Sweden. Huge building. Huge building, once again, air changes under every 10 seconds. Air going around that building, 30, 40 kilometers an hour. Down to minus 40. That happens to be a wooden construction building, and that's based just on pure fresh air around what we're calling our cloud cooler. That really simple device, which, forgetting about humidity, can give us, low humidity, can give us really 100% compliance against some of the against the main ASHRAE standards. So this is how we create a huge density data center with massive airflows, massive power, but still give the conditions which are equivalent to looking after your highest grade IT equipment in a tier 3 or 4 data center. Another thing we're very proud of. This is UK manufacture with our European partners. So as EcoCooling, we design everything ourselves. We write all our own software. But our key partners, we have our Italian controls from Corel. We have our German fans from Zilebeg or EBM pads. We have Swedish cooling pads. Goes on. So most things are sourced in Europe. We're very proud of that, and we will continue to do that. On the control side, controls are very important because, once again, to get the right level of cost, it's all about dark rooms, remote access, VNC, outside. So, that gale of creative destruction, we are breaking records on power density and airflows, speed of response, speed of build, lowest total cost operation, using all those elements of modularity, fresh air cooling, no redundancy, all those things. And our different variations of the 3 concepts of the cloud cooler, our edge cooler, which is more closely kind to a data center, and the blockchain cooler, which will be the system of the new emerging markets for GPUs onto artificial intelligence, driverless cars, all those things of the future. The red lights come on, I've used my time up.